You scroll through your Instagram feed. It feels so simple, right? Almost like magic. But behind that one little swipe, it's one of the most mind-blowingly complex engineering systems on the entire planet. So come on, let's pull back the curtain and see the architecture that makes the impossible look so easy. Okay, to really get a handle on the scale here, let's just talk about the data. Every single year, Instagram has to find a place to store, get this, over 1981 petabytes of new stuff. We're talking photos, videos, stories, all of it. To put that in perspective, that's almost 2 million terabytes. Just let that sink in. Dealing with that constant flood of data, that's the first huge, monumental challenge they had to crack. And you know this giant digital system? It's not just living in the cloud. It has a very, very real-world impact. I mean, it's gotten to the point where restaurant owners, shop owners, you name it, they're literally designing their physical spaces with one goal in mind. We want it to be Instagrammable. Think about that. The code running on servers is actually shaping the way our cities look and feel. That's wild.
So how do you get that kind of influence? Well, you have to solve one of the gnarliest problems in software history. You've got this app, right? It was built for a handful of users. How do you turn that into a global monster that serves billions of people every single day? That's the billion-user problem. And the answer was to go from one big, clunky piece of code, what we call a monolith, to a whole swarm of tiny, specialized microservices, all working together.
But you know, it didn't start out complicated. In fact, it was the opposite. Their first engineering motto was brilliant. Do the simple things first. See, in the early days, they made a really important trade-off. They decided that getting features out the door fast was more important than having the fastest code on the planet. So they picked Python and Django, not because it was the most high performance, but because their engineers could just build and ship, super, super fast. And that one pragmatic choice, it basically set the stage for everything else. All right, so let's dig into that first massive problem, storage. I mean, where do you even put billions and billions of photos? You can't just shove them into one giant database. It would just fall over and die. No, you have to get really clever. How do you identify every single image? How do you organize it? And most importantly, how do you find it again in a fraction of a second? The secret sauce here is a technique called sharding, and it's actually a pretty simple idea. Imagine a library with billions of books just thrown into one giant pile. It's chaos, right? You'd never find anything. Sharding is like organizing that library. You create thousands of smaller, neatly labeled shelves. Now, finding the exact book you want is suddenly super easy and incredibly fast. That's what they do with your data.
So let's look at how Instagram actually does this. What's kind of funny is they didn't go for some new, flashy NoSQL database. Nope. They stuck with good old reliable PostgreSQL. They split all their data into thousands of these logical shards. Think of them as digital shelves. Then they map those shelves onto real physical servers. And here's the genius part. All of your data, your photos, your DMs, lives on a shard that's determined by your user ID. Why is that so smart? Because it means the system can scale forever. Need to add another million users? Cool, just add more servers. It's this beautifully simple, linear way to grow.
Okay, but wait, this whole sharding thing creates a brand new, really tricky problem. Picture this, thousands of servers all over the world, and at the exact same millisecond, a bunch of people upload a photo. How in the world do you give every single one of those photos a totally unique ID number? You can't have them all call back to a central mothership to ask for a number. That would be way too slow. So what do? The answer is just so elegant. It's a piece of engineering inspired by Twitter called a snowflake ID. It looks like a random number, but it's not. It's actually a 64-bit secret code. The first 41 bits are a super precise timestamp, right down to the millisecond. The next 13 bits are the ID of the shard, the server, where the photo was born. And the last 10 bits? That's just a little counter that ticks up just in case two photos get uploaded on the same server in the same millisecond. The result? Every photo gets a totally unique ID that's also automatically sorted by time. And the best part? No central coordinator needed. It just works. All right, so we've got the storage figured out. It's rock solid. Now we can get to the part you actually see and feel every day. The feed, the magic algorithm. But here's the thing. It's not magic at all. It's just math. Really, really complex math, run by a whole orchestra of machine learning models. So the first job is just to find some stuff you might like. I mean, the system can't possibly look at every single post on Instagram for you. That's insane. So instead, it uses this cool thing called a two towers neural network. Think of it like this. Tower A is your personal stalker. It knows everything about you, what you've liked, who you follow, everything.
Tower B is a content expert. It analyzes every single post, the video, the audio, the text. Then, in a blink of an eye, the two towers talk to each other and find about 500 posts that are the best possible match for you. That's our starting pool. Okay, so we've got our 500 candidates. Now comes the main event, the ranking. A different system looks at those 500 posts and tries to predict exactly what you'll do. And here is the big change for how this all works today. The most important thing you can do is no longer a like, not even close. The number one most valuable signal, the thing the algorithm cares about most, is a send. When you share a post in a DM. Why? Because a send is private. It's genuine. It's not for public clout. It shows you really value that content. So if the algorithm thinks there's a high chance you'll send a post, boom, right to the number one spot in your feed. This perfectly curated feed is amazing, right? It feels so smooth. Well, it's amazing until, say, Taylor Swift posts something and 10 million people all try to view it in the same second. Then things get dicey. See, this whole system has to work while constantly being on the verge of getting crushed by a massive traffic spike. So how do they defend against that? How do they survive going viral? This exact scenario actually has a really cool name in engineering. It's called the thundering herd problem. Imagine that celebrity photo. It's been viewed so much that it's sitting in a fast cache. But eventually, that cached version expires. The very next moment, millions of phones all scream at the same time, "Give me the photo!" And they all stampede towards the main database. That herd would literally melt the database and take all of Instagram down with it. So to stop the stampede, they have this incredibly clever trick called a lease mechanism. Think of it like a nightclub bouncer. When the data expires from the cache, the very first request that shows up gets a special pass, a lease. The bouncer tells them, okay, you can go to the database and get the info. But everyone else, the millions of other requests that show up right behind, the bouncer puts up a velvet rope and tells them, hold on, just wait a sec. That one person with the lease gets the data, updates the cache for everyone, and then the bouncer lets the whole herd in to grab the fresh cached data. The database is safe. Crisis averted. You see these solutions, the snowflake IDs, the lease mechanism, they're all so clever, but they're also really pragmatic. And that all comes back to the core engineering culture at Instagram. It all traces back to that first motto, do the simple things first. And surprisingly, it also explains why Python is still king over there. There's this quote from an Instagram engineer, Hui Ding, that just nails it. Performance speed is no longer the primary worry. Time to market speed is. And that's everything, isn't it? In today's world, how fast your team can dream up an idea, build it, and get it into the hands of users, that is way more important than how fast the code runs on a micro level.
And honestly, that philosophy is their secret weapon. It's why Instagram, to this day, runs one of the biggest Python deployments on the entire planet. Yeah, Python, the language that so many people love to say, doesn't scale. For Instagram, it became a massive strategic advantage. Their engineers could just move faster than everyone else. It just goes to show you, in the battle for your attention, the winner isn't always the one with the fastest code. It's the one that lets their people build the future the quickest. And they don't just let it sit there, they really invest in it. A while back, they took on the massive project of migrating their entire system from Python 2 to Python 3. And they didn't just get some new features, they got this huge, unexpected payoff. A 12% drop in CPU usage and a whopping 30% drop in memory usage, all across the board. It's perfect proof that sometimes doubling down on the tools you already have can give you massive returns. So when you put it all together, what have we got? We have a system built on cold, hard math. Sharding, IDs, predictive models is all just logic and code. But the result is something that feels intensely personal. It's a feed that's now smart enough to know that what you share privately with a friend is more important than what you like for the whole world to see. And that kind of leaves us with this one last big question. What does it really mean for us when the math gets this good? When it stops just predicting what we'll click on and starts predicting what we actually truly value?